Welcome to the module on Drillstem Testing. Today we will learn about types of Drillstem Testing or DST, DST string components, DST procedure, DST periods, hydraulic jars, safety joint, slip joint, test valve, reverse circulation valve, gauge carrier, packer, and TCP and subsea valves. A Drillstem test, or DST, is a procedure for isolating and testing the pressure, permeability and productive capacity of a geological formation during the drilling of a well. The test is an important measurement of pressure behavior at the drill stem and is a valuable way of obtaining information on the formation fluid and establishing whether a well has found a commercial hydrocarbon reservoir. It is carried out to get following info. Is there a reservoir? What does it contain? At what rate will it produce? For how long? What facilities will be required? And what hazards are there? Types of drill stem testing. Open hole, hydrocarbons shows in cores or cuttings during drilling or indicated by logs. Hole be in good condition and consolidated, packer seat. Open hole limits the application of pressure on the annulus. Strings designed operated by pipe reciprocation and or rotation. Multiflow evaluator system, MFE, self-contained. Well may cave in on top of and string may stuck down hole. Cased hole, as open hole DST. Well cased off. Test interval be perforated, prior or during DST. DST string components. Packer, it serves as seal and isolates hydrostatic pressure, pH, from formation pressure, PF. Test valve, it is placed above packer, isolates cushion pressure, PC, from pH, and reduce effects of wellbore storage. Packer set test valve opened, flow to surface occurs. Reverse circulation valve, it removes produced fluids before pulling out of the hole. Slip joint, it is expansion or contraction compensation tool, changes in string length caused by T&P or hydraulically balanced or insensitive to applied tubing pressures. Hydraulic jar, it transmit an upwards shock to tool string when packer/lower assembly becomes stuck. Safety joint, actuated only if a jar cannot pull stuck tools loose. Safety valve, additional well control, main downhole valve fails. Gauge carrier, mechanical and electronic gauges placed in a carrier for support and protection. Sampling chamber tool, trap downhole sample as test without well shut-in. DST procedure. 1. Make up DST string and RIH. 2. Fill up DST string with light fluid, usually water. 3. MFE at interval be tested. 4. Set packers. 5. Open test valve. 6. Flow well. 1. Pre-flow. 7. Close test valve. 2. Initial shut-in. 8. Open test valve. 3. Main flow. 9. Shut-in valve. 4. Final shut-in. 10. Open reverse circulating valve. 11. Reverse circulate test string volume. 12. Shut reverse circulation valve. 13. Unset packers. 14. Circulate hole, and 15. POH DST string. DST string to bottom, 1 packer. DST string off bottom, straddle test, 2 packers. It may need jarring to POH string free. MFE to be sent for sample test, PVT. Recover DST pressure chart from gauge carrier. DST periods. 1. Pre-flow, clean up well, remove any supercharge given to formation due to mud infiltrating into prospective formation during drilling operation. 2. Initial shut-in, formation to recover from pressure surges caused during pre-flow closed in for the pressure build-up. 3. Main flow, lengthy production to test formation's flow characteristics. Fluid samples checked for water content, using set choke or variable chokes, measured and gathered for analysis in a laboratory. Samples of drill string content at end of test measured, volume in analysis. Flowing pressures and temperatures recorded. 4. Final shut-in formation pressure recorded pressure build-up. DST chart. It is a pressure transient analysis to define reservoir properties. Let us see the diagrammatic illustration on your screen. Hydraulic jars. Hydraulic jars used to free DST string in case of sticking. They are positioned below packers. Characteristics: hydraulic system hermetically closed to ensure proper functioning of the jars throughout sticking time or operation. Minimize rig operating time during sticking operations. Reaction time can be set, adjusted, and as required. Impact force can be adjusted within the limits of the hydraulic system. Safety joint. It is emergency disconnecting tool in case of string sticking without being able to free by jarring. The string above it is free upwards. Characteristics: installed immediately above packer. Need RH rotation to disengage, string turn to left. It has a tension sleeve with different tension values. 25.000, 30,000, 40,000, 50,000, 60,000. Slip joint. It is a telescopic joint account for T and P variation, avoid string movements relative to packer. Adjusting test string, 1.52 meters stroke. Number of expansion joint required depends on expected temperature, stretch and tension. String weight used to define expansion joint's position. Once weight on packer noted on weight indicator or calculated, expansion joint's positions defined. Test valve. When packer expands against the hole to segregate the mud-filled annular section from the interval of interest, the test valve allows formation fluids to enter the drill pipe during the test. The equalizing valve allows pressure equalization after the test so the packer can be retrieved. By closing the test valve, a build-up in pressure is obtained. By opening the test valve, a decline in pressure is obtained. During the DST, both pressures and flow rates are measured as a function of time. Reverse circulation valve. To remove the DST tool, the driller first opens the reverse circulating valve. It is opened hydraulically by pumping the drilling mud down the annulus. With the valve open, the drilling mud circulates down the annulus and up the drilling pipe to the surface. The drilling fluid kills the well by keeping the formation fluids under control. Then the packer is released either by rotating the drilling string or by the use of hydraulic jar. Gauge carrier. Field-proven gauges give quality data. The package arrives at the well site ready to run, which is ideal for testing in remote locations. Data is downloaded at the well site with our comprehensive software package and can be emailed to any location within minutes of the gauge being recovered. Packer. Packer is used in conjunction with DST tools and provides isolation of the formation for production or injection purposes. A packer is deployed in the safety position and has an integral bypass allowing fluid to displace from below the packer whilst running in hole. The packer can be reset as many times as desired by repeating the setting process described above and ultimately retrieved from the well with the rest of BHA on completion of in-hole operations. The packer withstands high flow rates, elevated temperatures, and high pressures when the appropriate slack-off weight is applied to the packer. The sealing elements effectively isolate annulus fluids from the perforated interval. Let us see a diagrammatic representation of the packer. Tubing conveyed perforation, DCP. DST or DCP combination ensures optimum perforation cleanup and provides reservoir performance characteristics. The system involves DCP guns run below a retrievable packer and a set of DST tools. Immediately after firing, the well is tested by alternately flowing and shutting in to develop the desired reservoir information. A well control valve can be used in conjunction with DCP to provide a quick look at near wellbore region by impulse testing. A longer duration drill stem test, DST, provides for a more detailed analysis of the commercial potential of the reservoir through observation of the types of fluids recovered and the flow rates. On your screen, representation of mechanical initiation system of tubing conveyed guns. Subsea valves. It is set in subsea BOP stack and actuated in case of emergency, bad weather, inclement weather etc. The entire tool is annulus pressure operated. A sequencing interlock system between the valves allows only one valve to be open at a time, which reduces operating times and minimizes the chance for operational error. Simple pressure sequences let you select which valve opens after closing both valves, allowing flexibility in the planned number of flow and shut-in periods. Let us now see a pictorial representation of riser disconnection. Anchors are recovered. Subsea test tree, SSTT, during offshore DST operations are performed on floaters for positive well shut-in, if emergency disconnect operations are undertaken. Thank you for learning with us.